Right, let's have a look at how to answer some of these questions then. So, apologies, these don't have proper equilibrium arrows. Sometimes they're a bit tricky to do in Word, but hopefully you can figure out where the equilibrium arrow should be. So if we have a look at question 2, the equilibrium concentrations of PCl5, PCl3 and Cl2 are as follows. So that tells me that all these concentrations are when we are at equilibrium. So to calculate the value of Kc, I can just substitute them in. So let's have a look and see if we can do that. So Kc is going to be, remember, it's your products over your reactants. So my products, I've got PCl3. So I have my value of 0.205 times by my value for Cl2, which is also 0.205, and all of that is over the concentration of PCl5, which is 1. And then I would do that sum, find the calculation of Kc. Remember, if you have coefficients, they become powers, so be careful to include those. So that's quite straightforward. Let's have a look now at question 4. So the reaction for the formation, blah, blah, blah. So here's my equilibrium. A mixture of 1.9 moles of H2 and 1.9 moles of I2 was prepared and allowed to reach equilibrium. The resulting equilibrium mixture was found to contain 3 moles of HI. So my first numbers are my initial amounts, and then when it says resulting equilibrium mixture, any number after that is when I am at equilibrium. So the wording gives me a clue that I need to do one of these ICEE tables. So let's put one of them in. So I need a table. So I need to write my equilibrium at the top, and then I need my initial amount, my change, my equilibrium moles, and my equilibrium concentration. So here I've got H2, apologies for not doing my subscripts, I2, and this is my HI. And remember to include your coefficients because that's important for the stoichiometry. So so remember it's ICEE. So it's an ICEE table that we've got. So first we have initial moles, then we have change in moles, then we've got equilibrium moles, then I've got equilibrium concentration. So I'm going to put my numbers for my initial amounts in the correct spots in the table. So there we go, those are my initial amounts. And then because they haven't told me about the amount of HI at the beginning, I'm going to assume that that is 0. So after it says at equilibrium or the equilibrium mixture contains, the numbers after that go in the equilibrium moles. So at equilibrium, I know I have 3 moles of HI. So I can fill that bit in. So now I need to fill in the change in moles line, and this is easy to do. It's easy to spot where you need to do it because it's the only position where you have an initial amount and an equilibrium amount. So I started with 0, I've ended up with 3, so this is plus 3 moles that have been made. So if I've made 3 moles of HI, I need to look and see how I've done that, and the stoichiometry is 1 to 2. So if I made 3 moles of HI, I must have used half as much, so minus 1.5 moles of iodine and 1.5 moles of hydrogen, because they're each at a 1 to 2 ratio with the hydrogen iodide and a 1 to 1 ratio with each other. So remember, For stoichiometry, you can compare anything to anything else. The stoichiometry only works at this change level. Okay, it doesn't work at on any of the other lines. So then you can do the sums to work out the equilibrium moles. So 1.9 minus 1.5 is 0.4 and 0.4 here. And then because these are moles, we can't always put them into our expression for case C. So the equilibrium concentration is your moles that you have over the volume, remembering to convert the volume to decimeters cubed. Okay, and they have told you the volume in the question. Remember, I mentioned the other day that they might not always give you the volume, and in fact they wouldn't need to give you the volume in this case, because in our KC expression we have the same number of things on the top and bottom of our expression, and the volumes cancel out. So we could have just put the moles into the KC expression in this case, because we have the same number of things top and bottom of our KC expression. So then I would work out my equilibrium concentrations and put them into my KC expression, remembering it's products over reactants, and remembering to make my coefficient of a 2 become a square for my HI value.